Chapter 4, Chemical Quantities and Aqueous Reactions. So your book uses the debate about global warming and greenhouse gases and carbon dioxide levels sort of as a kind of an interest grabber, or to help you relate study of chemistry to real-life topics. I'm not going to test you on any of the stuff about the greenhouse issue. Carbon dioxide is one of the greenhouse gases, and it is very important for our planet. It acts almost like a blanket to keep our planet warm. But too many blankets and the planet gets too warm. It's like the glass on a greenhouse that allows the sun to come in, and the sun hits things inside and gives off warmth, but then the glass ceiling keeps the heat from leaving. And that's how greenhouse gases work. There's a balance between this incoming energy and outgoing energy, and that's what determines the Earth's average temperature. So scientists have been measuring stuff for a long time. Here's a couple of graphs showing this is the temperature change, global temperature, from about 1880 to 2011, it looks like. And we see that there is definitely an increase, there's an upward trend in the temperature here. That graph can be rather alarming, but look at the amount of temperature variation here. This is from minus 0.4, so 0.4 degrees Celsius below average, to 0.8 degrees above average. So there's been an average 0.7 degrees Celsius rise in temperature since 1860. That's over 150 years. If we look at the variation from year to year, there's a lot of variation from year to year. There does seem to be a trend. The question I have, though, is you see these little ups and downs and ups and downs. Is this perhaps part of a larger up and down curve? That's really hard to determine. Very knowledgeable scientists can argue over and over and over again, around and around, about whether this data really means anything or not. Here's a graph of carbon dioxide concentrations in the air over the same span of time. And here they've risen from about 290 parts per million to 390 parts per million. And so we have seen this steady increase in carbon dioxide. The question is the carbon dioxide causing the global temperature increase? Could it be the other way around, that the global temperature increase is causing the CO2 to rise? Or is it more coincidental, that they just both happen to be rising at the same time? Those are the sorts of questions that scientists have. Well, where's the carbon dioxide coming from? One source is combustion reactions. When hydrocarbons are burned, they give off carbon dioxide. So here's a balanced chemical equation for the combustion of, what's your best guess for the name of this compound? Octane. So C8, C8H18, this is octane. Octane is present in gasoline. Octane reacts with oxygen, forming carbon dioxide and water. So my husband drove his car and I rode along. But we put some carbon dioxide in the air as we came to work today. You have a natural gas stove at home and you cook a hamburger. You've put some carbon dioxide in the air. But on the other side, you also have the plants outside who take the carbon dioxide out of the air and turn them into cellulose and different things. And so it's used as well. So combustion of fossil fuels is definitely a source. And then another source is volcanic action. Volcanoes, whether they're fully erupting or they're just, spitting out gases, they put a significant amount of carbon dioxide into the air. How do we know which is which? Is this increase natural? Is it from fossil fuels? Are we doing it? I don't know. So that's kind of the introduction to stoichiometry.